In the last couple of videos, we took a close look at the tan theta graph, and we saw that the tan graph was very different from the sine and cosine graph. Here in pink, I've got the tan theta graph from 0 degrees to 360 degrees. And we can see that between 90 and 270, in this 180 degrees over here, this is where we have one period of our tan graph. Our tan graph is going to look like this shape, and it's going to repeat over and over and over. And what we have here from 0 to 90 is just half of our tan graph. We have the second half of our tan graph here. And over here from 270 to 360, we've got another half of our tan graph, the first half of our tan graph. So I mentioned in the last few videos that while over here I'm just showing two quadrants of our Cartesian plane, quadrants 1 and quadrants 4, we also have two other quadrants on this side of the Cartesian plane. And at negative 90 degrees, we're going to have another asymptote. And at negative 270 degrees, that's further this way, we're going to have another asymptote. And that's where we're going to see the other half of this. We're going to see this curve going down here and approaching the negative 90 degrees asymptote. And then after that, we're going to see the same shape repeating again and again. So that's just something that's always good to keep in mind when I'm only showing 0 to 360 degrees, that this shape is actually going to continue repeating, and we're going to keep seeing these asymptotes every 180 degrees. And this is going to be important to note, especially for grade 10, because in grade 10, we are not going to be encountering any graphs where we need to shift this. In grade 10, you are always going to see your asymptotes for the tan graph at 90, 270, negative 90, negative 270, and every 180 degrees from there. So that is always going to be the case in grade 10, and only in the later grades are you going to see that change. So for now, whenever you are dealing with the tan graph in grade 10, it's always important to first and foremost just identify your asymptotes at 90 and 270 and 180 degrees after that and 180 degrees before this. It's good to always put in your asymptotes first, and then it's much easier to draw in your points after that. So in this lesson, we're going to look at how the tan theta graph can change with different values of a and q. So let me just quickly make a note that the general form of a tan function is f of theta is equal to a tan theta plus q. This is going to be the general form that you're going to find tan functions in. You can have different a values and different q values. And so far, we haven't really seen how these different values are going to affect the appearance of this basic tan graph. So let's take a look to focus on q first. Let's see what the effect of q is. So q, as you might be guessing from our previous videos, is the vertical shift. This is what we saw with sine, with cosine, and this is the same trend that we saw with a lot of our different types of functions. Q has often represented our vertical shift, and it's going to be no different in this case. So that means if we have a Q greater than 0, we're going to be shifting our graph upwards, and if we have a Q less than 0, we're going to be shifting our graph downwards. And let's take a second to actually understand why this is the case. Let's look at an example here, where our function f of theta is equal to tan theta plus 2. So here we have a q value of 2. We can tell because this is greater than 0 that our graph is going to be shifted upwards. But let's actually conceptually see how this vertical shift is going to make sense. So we know that tan theta at certain angles is going to be either -1, 0, or 1. We know that at 0 degrees, it's 0. At 45 degrees, it's 1. We have our first asymptote at 90. Then here at 135 degrees, it's going to be -1. At 180, it's 0. At 225, it's 1. At 315, it's -1, and at 360, it's 0. That is always going to be the case. At these specific angles, your value of tan of that angle is always going to be these values. So what is going to happen when we are adding 2 to that? Well, let's start off with here. At this point, our tan of 0 degrees is going to give us a value of 0. But this function tells us that it's going to be whatever that value is plus 2. So here where we have 0, it's going to become 0 plus 2. So this point, instead of being a point at 0, is going to be a point at 2. So we're going to write down our first point right here. Now here at 45 degrees, where our value of tan of 45 was equal to 1, now we're going to get 1 plus 2. So here it's going to become 3. So that means that our point is going to move up here. At 90 degrees, we're still going to be undefined, so our asymptote is going to remain here. Over here, where our tan theta of 135 degrees here, is -1, and now it's going to become -1 plus 2, which is 1. So our point is going to be here now. Over here, where tan theta is 0, we're going to get 0 plus 2. So this is going to be at 2 now. And over here, where we had a value of 1, now we're going to have a value of 1 plus 2, so 3. So this point is going to move up to 3. And here we're going to see the same trend. So where here, over here, it was -1. So now it's going to be -1 plus 2, which is going to be 1. So this is going to be a point at 1. And here where we had a value of 0, now we're going to have a value of 0 plus 2, which is 2. So our point is going to be at 2 over here. Now if we connect these dots together and draw our tan graph, we can see that our graph has just been shifted upwards. So it's going to look exactly the same as the graph in pink, except we've shifted everything up 2 units. So the shape of these curves has not at all changed. Between the purple and the green curves, our shape has remained the same. The only thing we've done is shifted our entire graph up 2 units. Now let's do the same thing with a q less than 0. Let's say our function was f of theta is equal to tan theta minus 1. Now we have a q of -1, so we know we're going to have a downward shift. So what's going to happen at these key points? So we know over here at 0 degrees, our regular tan graph had a value of 0. And now, because our function is tan theta minus 1, we're going to have a value of 0 minus 1. So we're going to have a point right here. Over here at 45 degrees, where tan theta is usually 1, we're going to have 1 minus 1. So it's going to be at 0. 1 minus 1 is equal to 0. Over here at 135 degrees, normally we have tan theta having a value of -1. And now we're going to have it having a value of -1 minus 1, which is -2. So this is going to become our point over here. Where we normally had a value of 0, we're going to have a value of -1. So that's going to be a point over here. And where we normally had a value of 1, now we're going to have a value of 0 because 1 minus 1 is equal to 0. So that's going to become a point over there. And we're going to see the same thing over here. So where we had a value of -1, we're going to have a value of -2. And where we had a value of 0, we're going to have a value of -1. So we can see here in this case, we have the same shape graph. All we have done is shift everything downwards by 1 unit. So if we look at this orange graph in relation to the purple graph, and remember the purple graph is our basic tan graph. So if we look at the orange graph, we have the same thing as the purple graph, just shifted down 1 unit. So we can see how conceptually it makes sense that Q is our vertical shift. When we increase our Q, we're shifting our curve upwards, and when we're decreasing our Q, we're shifting our curve downwards. However, the shape of our curve is going to remain the same. We're not changing the shape of this curve. All we're doing is shifting it upwards or downwards. So that is going to summarize the effect of Q. And in the next video, we're going to look at the effect of A. And I mentioned that the shape of the graph in the case of Q is not going to change. It just shifts it up or down. And we're going to see in the next video that A is actually going to change the shape of this graph. It's going to affect how steep and how wide this graph can look. So that's what we'll look at in the next video.